In this video, we will start to look at the second method we can use to do the diagnostics. So basically, this tests allow us to check if our model, after we feed in our time series data to our AR-IMA model, are we able to generate in the white noise or not? Okay, so this test is called a Ljung Box Statistics. And as you can see, the expression of this statistic, it is involving the number of the observation, which is represented by n, and the m is the time lag to be tested. So there is a rule of thumb here. So when we're using the forecast X, so if your data, you don't have any seasonality in the data, so the test of the m, the number of the time lag will be equal to 12, okay, equal to 12. However, if your data has a seasonality, so for instance, you have the quarterly, every quarter you have some seasonal pattern, and so in that case, the number of the time lag will equal to 4 times your seasonality. So if it's a quarterly seasonality, so what we're checking here will be 4 times 4 equal to 16. So the m value will equal to 16. So how about you have a monthly seasonality? So every month you have different patterns, but they repeat every year. So in that sense, the m here will equal to 12 times 4. That will give us 48. Okay, so the m is the number of the time lag to be tested. And then the RK is the sample autocorrelation function of the kth residual term. So like I said, in this class, we're focusing on practically how we're getting results. And so you don't have to understand every component here. But this is the statistic the forecast X will use to calculating the Ljung Box statistic. Now that we are able to see the result directly from the forecast X audit report. Okay, here I want to re-emphasize in the notation again, because when we are doing this Ljung Box statistic, after we receive the statistic for on the forecast X, we actually has to making the decision by ourselves whether we should rejecting the HO, H non or H alternative. So for the Ljung Box statistic, the HO is the non-hypothesis for this test is actually the series, the time series we're dealing with is white noise. So basically, if the statistic we will receive from the Ljung Box statistic is larger than the critical value we will be able to get from our Excel, and then we will reject our non-hypothesis and to believe the time series we're dealing with is not having white noise. So therefore, if we fail, if we did end up rejecting the null hypothesis, we need to go back to adjusting our model again. Okay, so this is the Ljung statistics. So now, after you understand how it look like, and we're going to call out practically what we're going to do. So the Ljung Box or Q test, statistic test, is testing whether the residual autocorrelation as a set are significantly different from 0. If the residual autocorrelation are significantly different from 0, the model specification should be reformed, or we need to go back to readjust our tentative model. And so in other words, that means the model has failed the test, so we cannot. So if we calculated the Ljung statistic is less than the table value or the statistic we can calculate using Excel, so the autocorrelation are not statistically significant different from 0. So that's what we are looking for. Okay, so we're looking for this statistic is less than the critical value. We can calculate using Excel or can find the chi-square table. So forecast X is set to check automatically for a lag length of 12, as I mentioned, for non-seasonal data. If we're dealing with seasonal data, so that length will equal to 4 times of the seasonal length. Like I said, that's the value for the M. Okay, so here I'm showing you the audit report from the forecast X for one of the AIMI model. As you can see in the section called Audit Trial Statistics, and the highlighted on the screen, that is where you can find the Box-Jenkins estimated value, right? Okay, so in this case, the software already did a bunch of iteration to find the best model. So therefore, we don't need to give the model any input as our tentative model, because the model itself can identify the optimal value for P D, and Q. So as we already emphasized, what's the meaning for P, D, and Q. So based on this result, our model decide where the time series does not need to have any AI term. Therefore, the first entry in the expression here, let me call it out. So therefore, the first value here is 0, right? And then the second value is about integrated. How do you want to differentiate the data? So that's basically showing our data is stationary. So therefore, we don't need any differentiating for the data. So therefore, the value for D is equal to 0. However, we are for the MA term is equal to 1. So we need a 1 MA term. So in that sense, it means our model actually, if you are able to plotting the ACF diagram, and you will see that there is one spike in the ACF diagrams. And so also you can see there are like 3 more number at the back. So we will talk about it later when we look at the data that had the seasonality. Okay, so this is the P, D, and Q. And on the right hand side, you will be able to see this statistic. So in the video later on the computer lab exercise, I will show you where you need to check the box and to show this Ljung Box Statistics. So basically, we are using this statistic to help us to determine if the model we have here are able to converting the time series data to the white noise. If that's the case, we believe our model, the black box we designed here, which is ARIMA001. So this model is a perfect fit to use to forecasting the time series data we're analyzing here. Okay, so now the question is, given the value of the statistic 7.33, shall we reject the H non? So to answer that question, we need to either rely on the chi-square table. You are able to find it on your textbook, but I don't recommend use the chi-square table. There are several reasons. First of all, it is hard. It takes time for you to find a chi-square table if you try to solve a real-world problem, right? You're gonna go find somewhere where's the chi-square table. Second, the chi-square table are limited, so it's a different combination of the level of the significance and the degree of freedom. Okay, so it is very limited. However, if you have Excel, I'm sure if you have the laptop, they all have Excel. So we actually can use Excel to help us to calculating this critical value. So therefore, for this class, I want my student use Excel to calculate a critical value instead of a chi-square table on your textbook. Okay, so so what kind of formula we're going to use to calculate critical value? So the formula is called the chi.inv.rt. So we are using the right tail test to right tail chi-square test to test our Ljung Box Statistics. Okay, so for this statistic, we plug in equal to chi.inv.rt, and then the significant level usually defined in the question, so it's 0.1 level, so I use 0.1. So the difficult part is the second entry, which is the degree of freedom. So the degree of freedom is equal to the M minus P minus Q. So we just spent a lot of time to explaining what is M, right? So the M is the number of lag we use to creating our Ljung Box statistics. And then by default, if we don't have any seasonality, the M here value will be equal to 12, okay? And the P and the Q, we've been using that during the whole semester, also the whole lecture of this chapter, right? So the P is the number of the AR term, and the Q is the number of the MA term, right? So in this case, since the model we use is 001, so this is my P, this is my D, and this is my Q, right? So therefore, we have 12 minus 0 minus 1, it gives us 11. So that's where the second number, 11, the degree of freedom coming from. So once we apply this formula, and then we will be able to receive the critical value, which is 17.275. So that's my critical value. So since in this case, the Q test I believe 7.33, so this is coming from our forecast X, is less than the critical value. So therefore, we are not able to rejecting the H naught. That is, the series we're testing here is a white noise, which is what we desire, right? So therefore, the ARIMA001 is the best model or best black box that can be used to forecasting the time series we are forecasting here. Okay, so again, to recap, so every time you run the forecast X, it will give you the model that already went through multiple iteration, and we believe that's the best model to capturing the pattern in the initial time series data. However, to assure this is the best model we are dealing with, not to blindly trust the algorithm, and we need to check on the Q test. Ljung Box will report the Q test. So for this Q test, the statistic given to you will be used to compare with the critical value that you need to use the equal to chi.INV-RT to calculate. To calculate this critical value, you first need to know the level of significance. So because that's the first entry. And then the second entry is the degree of freedom. That will be calculated by use M minus P minus Q. And the M by default, if the data does not have seasonality, that will be 12. And the P and the Q is coming from the ARIMA models, and then that will give you the value for the second entry. Okay, so if the statistic calculated through the forecast X is smaller than the critical value you calculate using Excel equation formula, so that means the model ARIMA received from the forecast X is the best a good fit for the time series data. Then you can use the model to do the forecasting. However, if this Q test statistics is larger than the critical value, and then we need to go back to look at our diagram again, ACF and the PACF based on the residual data to see are we need to including more AR term or more MA term, or we need to increase the value of the integrated the D value. Okay, so this is the hypothesis testing. So this is the second method to go through the diagnostics.